Okay, so I want to give you guys the coolest piece of mathematics that exists before Calc 3. Okay? Yeah, you have to wait a couple more semesters before you see something that's cool. But good news, it comes back in Calc 2. So you get to see this again in Calc 2, and you'll know why there. Because right now what I'm going to say is, trust me. Okay? This is one of the few things I'm not going to justify to you at all. Just got to trust me on this one. Oh, let me leave the r's off too. Let me just write Euler's in there. So, e to the I theta. You guys know and love this thing, right? Yeah, remember that's the base of the natural logarithm, right? This is a number e, which is named after this guy, Euler, because calculus, and because he's a really smart guy. So I have e to the I theta is cosine theta plus I sine theta. Okay. That looks like a complex number, because it is. So you want to see the geometry? Okay, and you're going to have to trust me on the fact that this e makes sense in here, because right now it doesn't. So here's a point that's a plus bi, right? You guys with me on that?
Yeah.
So I went, how did I get there?
Over A at B.
Good, I went over A, so this side's A, this side's bi, right? But if I'm just labeling the side of the triangle, it's B. You guys with me on this? If this angle here is theta, then what should this side be? Let me add one more caveat. I'm going to put a 1 here. You can trust me that that's this 1 here. So those ones go together.
So A should be
This theta here
A
and that theta there go together.
over
So,
A over 1,
yeah, cosine of theta should be A over 1, right?
right? Just
So A should be cosine of theta. That's the real part. You guys see that? It's no coincidence that this cosine thing and this thing make that thing, right? It's all the real stuff. So you're looking in the real direction and you're saying, hey, that's cosine of theta long. So I put that here. How about the B side?
I sine theta.
Yeah, that should be, B should be sine theta, right? And then it's in the I direction, so I put an I there. You guys want to add the R's to this formula?
Yeah.
Okay, so what's Euler's identity with the R's in it? That's going to be R e to the I theta. And what's that going to be?
R cosine theta.
R cosine theta plus,
R I sine theta.
yeah, I'm going to write the I first just to get it out of the way. So I R sine theta.
And this is going to be multiplied.
Yeah, and everything there is, so these are multiplied. And the thing I want you to remember is that this, so this R is playing the role of the radius, right? Just like usual. Right, from where? Like radius from,
The origin.
yeah, the origin in, where do I come up with a radius? That's from, yeah, unit circle thoughts. That's really polar coordinates, right? So that's playing the role of the radius from polar. This theta here, that's playing the role of the,
Second coordinate.
yeah, the second coordinate, the theta from polar. You guys see that? This gives me a nice, easy form for converting, right? From kind of rectangular style things to the polar style things in the complex plane. Is cool with that? You want to use this to multiply a couple numbers? Maybe?
Yeah.
All right.